Here's question number 3, your free response question for the day. So in question number 3, you're given a graph, and the graph is that of G. And you see a line segment, you see a half a circle, and then another line segment. And the graph consistentness says that. Anyways, here, F is defined using G, and you can see the equation that's happened. So let's start with A, and how would we answer it together? So can you find F at 7? First question. So we write it down. Wherever there's an X, I'm going to put in 7. And then I'm going to answer it. So obviously 3 times 7, that's 21. Hey, that's the easy part. Can you integrate from 0 to 7 off a graph? Again, area under a curve, area above is positive, area below is negative. So from 0 to 7, you can see half a circle, and it's below. So the area of a circle is pi r squared. So in this case, the radius is 3. And then I'm going to divide pi r squared by 2 because it's half. And I said because it's below the x-axis, that's going to be negative. And then what's the part above? See the rectangle here? That part that goes all the way to, oh no, we're going to 7. So do you see that rectangle to 7 still? And it's 1 by 3. And it's above, so we're going to add 3 to that. And that's it. We don't need to simplify that any further. Perfect. Can you take the derivative at 7? So if I take the derivative, I first below need to know what the derivative of x is to begin with, of f. So the derivative of 3x is 3. And when you take the derivative and integration, they undo each other. This is the fundamental theorem of calculus, and you do a substitution, and you're just left with g at x. So that's applying the fundamental theorem of calculus. So it's 3 plus g at x. So now I can go above, and where there's an x, of course I can put in 7. Now g at 7, here, what's the y value up here? It's 3. And that's a great answer. Or you can write down 6. Not too bad, right? All right, let's look at part B. So I adjust things here. Here's part B. It says find the value of x in the closed interval -4 to 3, which f attains its maximum value, and then justify your answer. So we're looking for a maximum there. So to find a maximum, we're going to take the derivative. We're going to take the derivative That's true. All right, so if I want to know which that is, take the derivative, find the x value. If I make it equal to 0, g at x equals -3. That'd be a turning point in terms of like what we're looking for g, for f. So -3 from -4 to 3, let's look at that. So from -4 to 3, something happens at -3 in terms of what's happening. But that's going to mislead us, I think, as I'm trying to think through. So at which f attains its maximum value from -4 to 3. So let me just think through this just for a second. All right. All right. So at -3, all the way, or -4, I should say, all the way to +3. What you notice all the way through is what are the y values there of g, and recognize that the y values at g that when you plug in will always be, I'm going to go in a totally different direction. Notice the y values here go from positive 2 to negative 3. So when I look at this derivative, if it goes from positive 2 to negative 3, there's never an answer that is negative for the derivative from that interval. So from negative 4 to positive 3, the derivative is always greater than or equal to 0. That means this is increasing. And then at the one spot where it's not increasing, which one gives you the y value? That's at 3, right? Because if I said g at x, I'm going to go back to this. At what x value does g at x equal negative 3? And that answer is when x equals 3. So if I understand this, from negative 4 all the way to 3, the answer is always positive. Now, after 3, it's going to change. In fact, after 3, it still remains positive. And that could be like a point of inflection because it doesn't keep going down from there. But here's the whole point, is that it's increasing from negative 4 to 3. So where does it attain its maximum value? And the answer is when x equals 3. Why is that? Because whatever the number is here, it's just going to increase all the way until it hits 3. So when does it retain its maximum value? And why is that? Because from negative 4 to 3, it is increasing the whole time. So that means it must attain its maximum value when x equals 3. A little bit tricky, little looky thing, right? Kind of question. All right, part C. For each of the limit from the left and from the right for g, find the value or state if it exists or does not exist. So the limit of the derivative of g. So what is the derivative of g? And does it exist at it or not? So from the left, so we're looking at g, the derivative so from the left, it's a line. So from that line to the left, it's just the slope of that line to the left. So what's the slope of that to the left? So it's down 2 and to the right 4, or down 1 and to the right 2. So the slope there is negative a half, or negative 2 over 4. So from the left, as it's approaching 0, the derivative is negative a half. When I look to the right, the derivative does not exist. So when you look from the right, what's the derivative there? And you have a vertical tangent right there. So because of that vertical tangent as you come from the right, it means the derivative doesn't exist as you come in from the right, but from the left it does exist. All right, last one, part D. Can you find the limit as x approaches negative 2 of this? So because I see a fraction, I'm going to separate this. This could well be L'Hopital's rule. But to show that, we need to separate the numerator and the denominator and show that both the numerator and denominator equal 0. So if I plug negative 2 into f, remember what f is again. So that's 3 times negative 2. That's f at negative 2, plus 7. So what's f at negative 2? That's 3 times negative 2. And then we're integrating from 0 to negative 2. Plus 7. So I get negative 6 plus 7. That's positive 1. And then if you integrate from 0 to negative 2, from 0 to negative 2 is a triangle. Half the base times the height. That gives me the answer 1. But because the bounds, the greater bounds on the bottom, that's actually a negative answer then. You just do the opposite of what you see, opposite number of what you get. Notice the greater bound is on the bottom and the smaller bound's on top. You do the same work, you just do the opposite answer when you get it. And the top is 0. The bottom, when I plug in, is e to the 0 minus 1, and we know that's also equal to 0. So this is indeterminate. So we're going to do L'Hopital's rule. So L'Hopital's rule, we're going to take the derivative of the numerator and the derivative of the denominator. So the derivative of f is f prime at x plus 7, well, the derivative of 7 is 0. The derivative of e to the 3x plus 6 is e to the 3x plus 6, but it needs a little hook of positive 3. And the derivative of negative 1 is 0. Now we substitute in. So it's the derivative at negative 2. And then in the denominator, you just have e to the 3 negative 2 plus 6 times 3. So the denominator is going to be negative 6 plus 6, which is 0. E to the 0 is 1. So the whole denominator is just going to be 3. What's the derivative at negative 2? So the derivative of f is right here. It's 3 plus g at 2. So I'm going to write that down. 3 plus g at negative 2. So what's the y value when g is negative 2? And the y value here is 1. So it's just 3 plus 1 over 3 or 4 over 3. And that's it. Good job. Thank you for doing your free response question today as we thought through it together. Part B was a little bit thinking question, but that's okay. Hopefully some of the other parts, we're getting each part a little bit more each time. That's the hope, and that you've kept motivated to keep practicing. And I'm motivated to keep giving you the videos to help you, okay? So Mr. G Math, over and out.